Okay, today's topic is operators. Okay, so basically, right, we need to understand some terminology here. Let us look at an expression here, a plus b. Okay, in this one, plus is called as operator, and a comma b are called as operands. Okay, a and b are called as operands. Okay, so basically what happens here, right? Basically what happens here is, okay, there are different ways of classification of operator happens. There are two ways actually. Okay, now if you look at this plus operator, it is working on how many operands here, right? Basically it is working on two operands. Okay, so we have something called as, right, classification, right? So first one is based on number of operands, right? So your operator is working on how many operands, right? That based on that we have, right, one type of classification. In this one you have unary, right? Next one is binary, the next one is ternary. Okay, so basically what is the meaning of unary? It works on, or it operates on, right, single operand. Okay, unary operator means it is a operator which works on, right, only one operand. So binary means what? It operates on, right, it operates, right, it operates on, right, two operands, right? So binary operator means, right, it is an operator which works on two operands. And the third one is ternary operator, right? It operates on three operands. Okay, so unary operator means it works on single operand. Binary operator means it works on two operands. Ternary operator means it works on three operands. Now this is one type of classification, right? Now if I give a mixture, if I give you an expression, right, which is mixture of all above operators. Okay, now question comes is which one we will solve first. Right, which one we will solve, right? Our expression is a mixture of unary, binary and ternary. Now the question comes is which one we will solve first. So it is called as priority. We will solve the expression, sorry, we will apply the operators, right, based on the priority of it. So basically unary operators have got highest priority, first priority, then comes is, right, then comes is binary operator which has got second priority, and then comes is ternary which has got least priority, right? So I will give you an examples based on this, right? We will work on that in the after some time. Okay, now this is one type of classification everybody should remember. This will help you to generalize and remember the different type of operators, right? The priority of operators in a generalized fashion. Now comes is another type of classification that we need to, right, look into it in a detailed fashion. Now we have to look at it in a detailed fashion. Now let's look at it, right? So there is second type of classification which is based on, right, the type of operation it performs, right? It is based on the type of operation it performs. For example, let's say, right, second type of classification based on, right, based on type of operation. right? Type of operation. Okay, based on type of operation. Okay, in this one, right, the first one we have is arithmetic operator. Arithmetic operator, right? Arithmetic operator. Okay, so basically what is arithmetic operators? It is an operator which performs a arithmetic operation. In this one we have five, right? Basically we have five. One is called as addition, right? The first one is called as addition, right? Second one is called as subtraction, right? Third one is called as, right, division, right? Division. These are the symbols I'm writing after that. Fourth one is called as multiplication. Multiplication, okay, which is represented by asterisk symbol. Okay, and the fifth one is, right, modulus operator, right? Modulus operator. So these are the five basic arithmetic operators we have. Now, apart from this, we have some more, right? We consider them as, we have some more. The first one is, right, unary plus. Unary plus. Second one is unary minus. And the third one is, right, increment operator. Increment operator. It is represented by plus plus. Okay, then we have decrement operators. These are the basic, right, arithmetic operators. All of them will come under, right, arithmetic operator, but in a generalized form we have only these five. But if we look at all these additions, plus sign, minus sign, right, increment, decrement, they all are arithmetic operations only, right? They all are, right, arithmetic operations only. Now let us understand, as everybody is aware about what is the meaning of addition, what is the meaning of subtraction, division and multiplication. Now let us go and understand what is the meaning of modulus operator. Okay, this is the modulus operator, right? Okay, now one second. I hope it is audible. Yeah, it is audible. Some network issues will happen. Okay. Now, what is the meaning of modulus operator? What is the job of this? It is used to find the remainder of two numbers. To find remainder of, right, of two numbers. Okay. For example, let's take an example, right? Int a, right, semicolon, a is equal to 15 mod 7. If I do this operation, right, the variable a will contain a value called as 1, because the remainder of 15 mod 7 is 1. Remainder. Now 15 divided by 7, 7 twos are 14 and 1 remains. So this is what is given by the modulus operator. Okay, now if you want to take some more different values, you can take a different values as well, right, to find the remainder of two numbers. Okay, one second. Okay, now let's take a value as like 14 mod 3. 14 mod 3. So if I do this, the remainder will be obviously 2, right? Remainder will be obviously 2. Now, if let's take another example, right? So 7 mod 15. Now look at this example, right? If the first number is smaller than, this is the first number. If the first number is smaller than the second number, then the remainder will be always the first number. So 7 mod 15 is 7 only. How it comes, sir? Right? 7 divided by 15. Right? 15 zeros are and remainder is 7. Right? Or you can understand this way, 15 into 0 plus 7, which is nothing but 7. So the remainder of, right, 7 mod 15 is 7. So remember that if the first number is smaller than the second number, then the remainder will be the first number itself. Now, are you clear on this one? Are you clear on this one? Okay, if you are clear on this one, then I'll give you some more information here. Now next comes is priorities. Next comes is priorities, right? There is another information that everybody must be aware about: priority of these arithmetic operators, right? So, right, the highest priority goes for multiplication and division, both, right? Multiplication and division have got a highest priority. Whichever comes first, we need to solve that first, right? And the second priority goes for modulus operator. Second priority goes for modulus operator. And the third priority goes for addition and subtraction. So these are the priority of the arithmetic operators. Okay, these are the priorities of arithmetic operators. Okay, are you clear on this part? Now we will look at what is unary, what is unary plus, unary minus, increment and decrement now. Okay, so let us start with unary plus, right? Unary plus. So means it is a plus symbol, right? It is not addition. It is a plus symbol. It's a sign, right? It's a unary operator. It works on only one operand. For example, right? I'm gonna write an example here, right? Int a is equal to plus 10. So this is called as unary, right? Unary plus. It is working on single operand. Similarly, if you go with unary minus, this operator works on single operand. For example, int b is equal to minus 6. So this minus is called as unary minus because it is working on only one operand. It is working on only one operand. Okay, now after this we're gonna learn with, right, we're gonna learn about, right, increment operator. Increment operator. So understand this example very well. Okay, understand this example very well. Okay, increment. Now in the increment operator there are two types. The first one is pre-increment. First one is pre-increment. Okay, first one is pre-increment. Okay, so what is the meaning of pre-increment? Let us observe that, right? So, right, first increment the value, first increment the value, first increment the value, and then, right, then use it in the expression. Use it in expression. Use it in expression. Okay, first increment the value, then use it in the expression. For example, let us take one example here and understand this better. Now int a is equal to 5. Okay, and there is another variable called as b. Now let's draw the memory of a and b. Let us draw the memory of a and b. Okay. Now, so what is the value present in a? It is 5. This is the initial value. This is the initial value. Now, how do we write pre-increment? Pre-increment is always written before the variable. Pre-increment is always written before the variable. So b is equal to plus plus a, right? What is the meaning of this plus plus a? The meaning of plus plus a is equal to a plus 1. This is the meaning of a plus plus a, right? So according to definition, what we need to do there? First increment the value of a. So if I increment the value of a, what does the a value becomes? It becomes 6. Increment the a value by one time, the a value becomes 6. After that you store it into b. After that you copy it into b. So now b value becomes 6. After this expression, a value becomes 6 and b value becomes 6. Are you understanding this? Right? Are you understanding this? Okay. Simple expression. Okay. Now similarly, if you go with post increment, if you go with the second one, post increment, post increment. So what is the meaning of post increment here? First, use it in expression, use it in expression, then, right, expression, then, right, first use it in the expression, then increment it. Okay. So let us take an example and understand this post increment. Okay. Now generally we will write the post increment symbol or the increment symbol after the variable. So initially let's take a is equal to 5 and another variable b. So initial value of a is 5. Initial value of a is 5. Okay. And there is a variable called as b. Now post increment is written b is equal to a plus plus, right? So first of all, what is the meaning of plus plus a? The meaning of plus plus a is nothing but a is equal to a plus 1. We need to increment the value of a. Its value will change. Its value will change. Now, right, according to definition, first use it in expression. So first what we have to do, use the a value and store it into b. If I store the a value for, right, into b, b value becomes 6. After that you increment the a value becomes 6. This is called as post increment, right? Are you clear on this part? Are you clear on pre-increment and post-increment? Very good. Okay, very good. Now, instead of this, right, there is another topic that is called as, right, decrement operator. Right, there is another topic called as decrement operator. So, what is decrement operator? Right, it is represented by, right, minus minus. Okay. Now, it's exactly like a, right, it's exactly like increment, but instead of plus 1 we will do minus 1. We will do minus 1. So in this also there are two types here, pre decrement, okay, So pre-decrement means what? First decrement the value, then use it in expression. Use it in expression. That is the meaning of pre-decrement. So if you take an example here, if you take an example, int, right, a is equal to 5 comma b. So there is a variable called as a and another variable called as b. So initial value of a is 5. Okay, so how do we write pre-decrement now? We will write the decrement operator before the variable. So what is the meaning of decrement? It is nothing but a is equal to a minus 1. Now according to definition, first decrement the a value. So a value will become 4 and then copy it into b. So b value becomes 4. So first, sorry, I think I have written increment. I need to write decrement here. Okay, first decrement and then use it in the expression. Okay, next, second one, right? Post decrement. Post decrement. So what we will do in post decrement? First use it in expression. First use it in expression. In expression, then decrement it. First use it in expression and then decrement it. So that is called as post decrement. Take an example here. Int a is equal to 5 comma b. So as per our declaration, we have two variables a and b. So post decrement is written always after the variable. Now what is the meaning of this decrement? Decrement is nothing but a is equal to a minus 1. But when to do it, it depends upon the definition. Now according to definition, first use it in expression means first use the value and put it into b variable. So initial value of a is 5. Put it in b and then decrement the a value, it becomes 4. Are you understanding? So both pre-increment, post-increment, pre-decrement and post-decrement. Are you guys clear on this part? Okay, very good. Okay, we will cover us one or two more operators and then we will start solving example. Okay, we will start solving example after that. Okay, so the next one comes is relational operator. Okay, second type of operator is relational operator. Relational operator. Okay, so what is the use of these kind of operators, right? These operators will help us. These operators will help us to express the relation between, right, two operands. They will help us to express the relation between two operands, right? Now, okay, so how many types we have? We have less than, greater than, less than or equal to, greater than or equal to, right, equal to, and not equal to. So these are the 6 operators we have in relational operators. These are the 6 relational operators that we have, right, in the C language. Now, one more thing we need to understand is, right, let us take an example and understand them. For example, int A is equal to 7, B is equal to 3, and variable C. Now, if I write C is equal to A greater than B, tell me this condition A greater than B, is it true or false? A greater than B, is it true or false? A greater than B, is it true or false? You can check A value is 7, B value is 3, right? So the A greater than B condition becomes true. So this one becomes true. If it is true, then 1 will be stored into C memory, right? In the C memory, it will store 1. So basically in our true and false, 1 is considered as a true and 0 is considered as false, right? 0 is considered as false, 1 is considered as true. This is how they operate. Now understand one more information here. Note the result of relational operators is always true or false. True or false. The result of relational operators is always true or false. You don't get any value other than 0 or 1. You will always get 0 or 1 from the relational operators. Okay, next. Are you clear on this relational operators? Are you clear on, right? Okay, very good. Very good. Okay. Now, right, let's go with a logical operator. Another type of operator that is called as logical operator. Okay, logical operators, right? So these will help us to, right, these operators helps to make logical decision, make logical decision, logical decision. Okay, now let us take understand how many are there inside this. So the first one is, right, in this one the first one is logical and, logical and. So it is represented by double and symbol. Then comes is logical or, right? It is represented by pipe. That symbol is called as pipe or parallel. You can call it as a pipe or you can call it as parallel. Then comes is logical not. Okay, logical not. Logical not is represented by exclamation sign. Now, first thing we need to understand here is the priorities, right? So the first priority is always given for, right, logical not. Why? Because it is a unary operator. It is a unary operator. That is why logical not will get the first priority. And the second priority goes for, right, second priority goes for logical and logical or both. Whichever comes first, right, we need to solve that first. Are you clear on these things? Now let us understand the logical operators working. So I'll take the first one, logical and. Okay, I'll take the first one, logical and. Okay, now, right, if you want to understand this, you need to understand the table of logical and gate. Okay, you need to understand table of logical and gate. Okay, so let us take the inputs as A and B and A logical and of B. So the table says that 0 0 output is 0, 0 1 output is 0, 1 0 output is 0. Only when both the inputs are 1, the output is true. Okay, so when both the input, if any one input, here I'll write down, if any one input, any one input is 0, then result becomes false. Result becomes false. Okay, if any one input is 0, then the result becomes false. Are you understanding now? Now let us take one example here and understand. Okay, int a is equal to 7, b is equal to -3, and another variable, let's declare it, called as res, right, to store the result. Okay, now if I write res is equal to a logical and of b. Okay, so here a value is how much? 7, right? B value is how much? 3. We need to perform logical and operation. So the result of this will be, right, true. The result of this will be true. Why? Because now all of you observe here. This for only for logical operators. Only for only for logical operators. Logical operators. I have to write in detail. It's okay. Only for logical operators. Okay, this is considered as 0, right? Only on the input side. I'm talking about only on the input side. They are considered as 0. But whereas, right, these are considered as non-zero. These 1 on the input side. In the input table, if you are having 1, these, right, so these are called as non-zero numbers, but the results are always, right, true or false, right? See, what I'm trying to convey here is the inputs are combination of, right, for logical operators, for logical operators, logical operators, the inputs are, the inputs are, right, inputs are combination of zeros and non-zeros, right, but the result is always true or false, but the result is always, the result is true or false. Are you understanding? The only the input these values, what we have written, they can be 0 or non-zero number. Non-zero number means it can be positive number or it can be negative number also. So if any number is there, right, so inputs are combination of zeros and non-zeros. but the result is always true or false, 0 or 1. The result is, right, 1 or 0. Inputs are combination of, right, zeros and non-zeros. The same rule applies for logical or operator, logical not operator as well. Are you understanding this part? Are you understanding? Okay, Gavin, I'll give you an example. See, for logical operators, let us take one more example. For logical operators, let us take one more example, right? Int a is equal to, let's say, 15, b is equal to 8, and another variable result. So there is a variable called as a, right, and b. So a is 15, b is 8. Now I need to find the AND operation, a and of b, right? Store it in the variable called as result. Now what is the value of a? Value of a is non-zero, and value of b is also non-zero. Now you go to the table, right, where the you have a non-zero combination as an input, right? Non-zero combination as an input. So in this case, right, what will be the result? The result will be true. Are you understanding? So this 15 and 8, they are representing 1 and 1 as an input in the table. So what I'm trying to say is that the one which is present in the input side, these are inputs. Okay, this is output. On the input side, in the table, it we have written 1. For logical operator, that 1 is nothing but non-zero numbers, right? Non-zero numbers. So the result will be non-zero logical and of non-zero. Non-zero logical and of non-zero is true. So 1 will be stored in the res. Are you clear on this now? Got it? Very good. Very good. Okay. Similarly, same rule applies for logical OR table also, right? Second one, logical OR. Okay, logical OR. Okay, logical OR. So again, you need to remember the table here for logical operators. Okay, right? So you will have two inputs A and B. The OR operation is like this, right? 0 0, 0 non-zero, non-zero 0, non-zero non-zero. So the one in the input is called as non-zero only for logical operators. Only for logical operators. Now the output will be 0 1 1 1, right? So for logical OR operation, for OR table, right, if any one input, if any one input is non-zero, then output is true, right? Output is true. Okay, now if you take an example here, if you take an example here, int a is equal to 6, b is equal to 5, and res. So res is equal to a logical OR of b. Can you tell me what is the value stored in res? Can you guys tell me what is the value stored in res? What is the value stored in res? Non-zero logical OR of non-zero. Very good, Galvin. Sorry, Gavin. I'm sorry if I may mispronunciate anybody's name. Try all of you. See, what is the value present in A? It is 6. Is it a 0 or non-zero number? It's a non-zero, correct? What is the value present in B? It is 5. Is it 0 or non-zero? Non-zero. Now go to the table and check non-zero logical OR of non-zero. What is the result of that? You will get that result. Are you understanding? What is the result? True. True is nothing but what? True is nothing but, it is nothing but 1. Now if I take A value as 0 and B value as 5, what will be the result now? What will be the result? What will be the result? Again true. Again the result will be true. Correct. Now if I take both the input as 0, what will be the result now? If I take both the inputs as 0, what will be the result now? Look at the table and answer. False. That is correct. False is nothing but 0. Correct? False is nothing but 0. So I hope everybody has understood logical OR operation. Okay. Now I'm going for logical NOT. Third one is logical NOT. Okay. Third one is logical NOT. Okay. Third one is logical NOT. It is represented by symbol NOT. So the table of NOT gate is very simple, right? Table of NOT gate is very simple. There is only one input, right? And NOT of A. This is how we write. So if it is 0, it will become, if it is 0, it will become true. If it is non-zero, it will become 0, right? So if you take an example here, int A is equal to minus 15, comma, result. Okay. Now result is equal to not of minus, sorry, not of A. Can you tell me what is the value stored in result? Not of minus 15. Not of minus 15 is how much? Obviously. Very good. Very good. Right? Come on, everybody. Not of minus 15. Minus 15 is a non-zero number, right? Minus 15, is it 0 or non-zero? It is a non-zero. Check if you apply not operator on a non-zero, what will be the output? It will be 0. Are you understanding? The result will be 0. Right? Everybody is clear now? Okay. If this A value is 0, then what will be the result? If I apply not operator, if A value is 0, what will be the result after applying not operation? Correct? Correct? Okay, very good. It will be true. 1. Right? Now, let us take one very simple example and let's mix multiple operators and learn. Okay, let us mix up some more operators here and learn. Let's take an example. Int main, opening bracket, int I is equal to minus 1, j is equal to minus 1, k is equal to 0, l is equal to 2 and m. Okay. Now m is equal to I post increment. Okay. Logical and of j post increment, logical and of k post increment, logical OR of L post increment. L post increment. Then after that, print the value of I, J, K, L, M. Solve it. Try to solve it. See, all of them are post increment. Post increment means should we increment first or should we solve it first? Should we increment first or should we solve first? Post increment means solve first. Correct? Sanjana, post increment. First use it, right? Post increment. Let's go back to that and see it. Post increment. Post increment. See here. First use it and solve the expression and find out what is the m value, then increment it. So first you need to, right, first you need to, right, so what you have to do is keep all increment aside, keep all the increment aside, first solve that expression and get the m value. After that you increment I, J, K, L. Take time and get the m value. Okay, let's see if anybody has solved it. Not yet. Keep all the increment on the side. If you can keep every increment on the side, what we will be left with? I, logical AND of J, logical AND of K, logical, sorry, logical OR of L. Solve this. After that, increment I, J, K, L. Okay, Manjari got it. Manjari got the value. She has got one answer. Okay. Manjari, find out what are the I, J, K, L values. After getting M value, you need to increment all of them. So find out what is the final answer. Okay, let's see who else has got. Still people are trying. Okay, try it, not a problem. Okay, let's see. Okay, I is equal to 0. Gavin got M is equal to 1. What happened? Are you able to solve or you are not able to solve? Please tell me that if you are not able to solve. If you are finding it difficult, please message. I'll explain this. Yes, Sanjana, that's correct. Now, should we solve it or have you got the answer? Should I help you to solve, or have you got the answer? If you reply, then only I can help you. What happened to all of you? Okay, should I help you? If you reply, then only I can help you. Okay, so chala. One more, I got one more answer. Srinidhi 0013. M value is 1. Yes, Srinidhi. K value becomes 1. Left to right. Yes, Sanjana. Right? Okay. Now let me help you with all of you. See, always remember that expression will be solved from left to right. Always the expression will be solved from. This is how we have to solve. Okay. Now next part is, right, all are post increment. All of them are post increment. Means what? First, post increment means what? First use it, then increment. Correct? Post increment means first use it, then increment it. Correct? So first keep all the increment aside. Keep all the increment on the side. Now, if you keep all increment on the side, this is what we are left with. Okay. So first solve this. Minus 1 logical AND of minus 1. What is the result? Minus 1 logical AND of minus 1. Can you at least reply me for this? Minus 1 logical AND of minus 1. So obviously the answer non-zero logical AND of non-zero. It is true, right? It is 1. Now you take this k value. Now you take this k value now. 1 logical AND of what is the k value? 0. Now 1 logical AND of 0 is how much? 1 logical AND of 0 is how much? 1 logical AND of 0. 1 logical AND of 0. What is the answer? 0. Obviously it is 0. Now you take this L now. You take the L. So OR operation of 2. 0 or 2. What is 0 or 2? 0 logical OR of non-zero. 0 logical OR of non-zero. Okay. 0 logical OR of non-zero. What is the result? It is 1. Correct. So this is the value which is stored in M. So M value becomes 1. Okay. Now what is remaining in the expression? What is pending in the expression? M value has become 1. M value has become 1 because it is true. Now don't you think we have kept increment aside? Now increment I value, increment j value, increment k, increment L. So the answer for this question will be 0, 0, 1, 3 and 1. This is our M value, right? So remaining are I, j, k, L values. So is every